we go over the equation of a circle. Now, look at this. This is the diagram, the Cartesian plane, where I've been given a circle. So the center of this circle is at this point. Now, let's say the value of x at that point, we can bring it there and say the value of x is a, and then the value for y, let's say, is b. So those are the values which are giving us the center. And so for us to be able to find the radius, what will be the radius? The radius is the distance from that point to this point here. Okay, just that point. Well, if we know the point A and the point B, so we can actually even join these 2 points, and what we are going to form is a triangle like that. And you know that for this triangle which we have formed here, it is a right angled triangle at this point, where this distance is equal to that distance. So if we know this point which is here, if we knew that point, say we know this is one value which is on the circle, let's say it is x1, y1, and then we know this other value which is here, it is also on the circle, that is x2, y2. So we are able to find the distance of first this straight line, the hypotenuse, this one here. So let me name it as, let me give it P. So let's say the hypotenuse is P. Alright. So like that. So how do we give the distance of that P? So the distance of P is given by x2 minus x1 squared plus y2 minus y1 squared, and then we square root. What we are using here is the Pythagoras theorem, because we know this is the hypotenuse, and then we've got these 2 sides which are the same. Well, if we find the value for P by using those 2 points, then we are able to find R, the radius. And how are we able to find R? Using the Pythagoras theorem, we know that P squared is going to be equal to R squared plus R squared. R squared plus R squared is 2R. So this will give us P squared being equal to 2R squared. And you know that P is equal to this portion. So we can actually even go on and substitute that value. Okay, and that is going to give us, let's go on, this is going to give us R squared. There is a 2 there, 2R squared is equal to, so where there is P, we are going to substitute what we have inside there. So that will be the root of x2 minus x1, that is going to be squared, and then plus y2 minus y1, that will be squared. Remember, this P is squared, so that will be squared. Therefore, to find R, that is going to be 2R squared is going to be equal to x2 minus x1 squared plus y2 minus y1 squared. And we are going to divide by 2 and then square root to remain with only R. So R is going to be x2 minus x1 squared plus y2 minus y1, that is also squared. This is being divided by 2, and then what we are doing is square rooting. Okay, we are square rooting because we want to do away with this square. So we can find the radius of this circle by using this equation. Well, what if we don't know the coordinates which are on the circle? So this radius, let's say we know the center, and let's say the center here, let's call it C, is the one which is A comma B. Okay, we know the center, and then we know one coordinate. So if we know the center and only one coordinate, we are able to find the radius. So the distance between this point, which we can see, between this point here and the center, that is what gives us the radius of this circle. And so that distance is given by we know that distance of a straight line is given by what? x2 minus x1 squared plus y2 minus y1 squared, and then we are going to square root. That is how we find distance. Now the distance is giving us a radius, so we are going to say radius is equal to, if we take this, the center as the first as 2, this is x2 and then this is y2, then that is going to give us x2 is a minus x1, which is the coordinate, squared plus y2 is b minus y1, which is from a point that is on the circle. So this is going to give us the radius of a circle. Well, we can go on and square both sides, and that is going to give us r squared being equal to a minus x, let me just call it x instead of x1, x squared plus b minus y, that is also squared. I can start by writing this portion this side, and so that is going to give a minus x squared plus b minus y squared, and that is going to give us what? R squared. Now when we did this, what we picked first, we first got the center and then we are removing a point. Wow, what if we said first that point that is along, that is on the on the circle, is what we are starting with. If we are starting with x and then with a and then x here, so it will be y and then minus b. So this equation is now going to be x minus a, that is going to be squared, plus y minus b, that is going to be squared, and that is going to be equal to what? R squared. So this equation which we have here is what gives us the equation of a circle. Okay, so this gives us the equation of a circle where this point here is the center. So b is representing the x coordinate, the y coordinate of the center. So where the center here, this point we can see here, which is inside with a, you just get the positive version, that is just a. This one, get the positive, so if it was a positive you need to get the negative, that is b, so that is the center. And then here r is the radius. So that is how we find the equation of a circle, using that. Now from all this that we can see, we need to derive some things which are very much important, because at times you just be given coordinates and then they require that you find the equation of a circle. And how are we able to do that if we just know the coordinates? Say you know about, let's say, 3 coordinates on this circle, and then we want you to find the equation of a circle. How do you get to do that? Okay, so we're going to use the same circle which we have at this point. Well, let me just redraw the circle so that we get to see how we are able to find the equation using only coordinates. Because if we have the center and just one point, we are able to, okay, if we have the center and the radius, we are able to determine the equation of the circle. But if you just have coordinates, how are we able to determine? So we go over that, we see how we are able to do that. So say this is a circle. Alright, it has got a center at that point. Now, when you've been given 3 coordinates on this circle, that is on this circle, so say this circle is passing through this point, it is also passing through this point, just any 3. Okay, it's also passing on that point. Now, if we say this is the point A, this is the point B, and then this is the point C. So if we join A, B, we can join any 2 points. So I can either join A to B and then B to C, or we can join A to B and then A to C or B to C and then C to A. It doesn't matter which one we join, as long as we've joined any two. So let's say we join these 2 points like this. Now if we join these 2 points, we should be able to find their equation. So what we need to know the equation of AB. Or let's not even say equation, but we need to know the gradient of AB. And how do we determine gradient? Gradient is a change in y over change in x. So whatsoever that we take, let's say this is A comma B. Okay, let me say A1 comma B1, and then let's say the coordinates here is A2 comma B2, and then let's say here it is A3 comma B3. Those are the coordinates. So the gradient of AB is going to be given by the change in y. So let's take this and then that. So change in y is given by y2 minus y1 over x2 minus x1. So our y2, let's get this one. Our y2 is what? Is b2. Our y1, let's take that as the y1. So that is minus b1. Over our x2, let's take this a2. And then our x1, which is a1. So this is going to give us a gradient of this line. Well, after finding the gradient, we need to find the equation of the perpendicular bisector. So in other words, we need to find the midpoint of AB. So we are interested in the midpoint of this point AB. So the midpoint is somewhere there. That will be the midpoint of AB. Now how do we find the midpoint? Midpoint is given by x1 plus x2 divided by 2, comma y1 plus y2, and also that divided by 2. So our x1 is a1, our x2 is a2 divided by 2, our y1 is b1, our y2 is b2, and then divide that by 2. So this is going to give us a midpoint. So this will give us this point here. Let's call it the point P. So this is going to give us a point P. Now if we find this point P, we need to find the equation of this perpendicular bisector that passes this equation, that cuts the circle. Okay, so what we are going to determine now is we are going to extend this line, and it goes like that. So we are calling it perpendicular bisector because it makes 90 degrees to the line AB, like that. So we need to find the equation of this line. But how do we find the equation of this line? Well, the first thing that we need to get to know is its gradient. Now if we know the gradient of AB, since this is making 90 degrees, two lines which are perpendicular, their gradient gives -1. So m1 times m2 is supposed to give -1. So say the gradient which we have found here is our m1. So the gradient for this line, let's say it's m2. So to find m2, what we'll do is the gradient that we found for AB, so let's call it as m1, we are going to divide. So this is going to give us a gradient of this perpendicular bisector. Now we know this gradient, of course we know the coordinate. The coordinate is here, we've already found it. Okay. So if that is a coordinate, and then we know the gradient, we're able to determine the equation. We know that y is equal to mx plus what? Plus c. So the y value here is this one which is here. And then the gradient is this one which we have determined, m2. And then what else do we need? Okay. Anyway, when we are determining the equation, we don't even substitute at those points I'm showing. We don't substitute here and there. Actually, if we do substitute there, then our interest will be to find the value for C. We can even go direct without finding the value for C. Now, if you want to use this method to find the equation of the perpendicular bisector, you are going to put your y, which is this point, and then you are going to substitute your x, which is this point. You are going to substitute there. You are going to substitute this gradient at this point, and then you find the value for C. After finding the value for sun, then you're just going to come in and substitute in. All you're going to substitute in is the gradient m. X is going to be the same, and then the value for c that you found, you substitute it there. Well, if you don't want to go that way, all you do is y minus y1 is equal to m x minus x1. You can use this equation to determine the gradient, the equation of the perpendicular bisector, where this is y, this y1 is the coordinate that you found, that is a y value of the coordinate that you found, that is there. Let's call that you found b, and then the gradient, this is a gradient of the perpendicular bisector which you've already calculated here, and then x1, let's call it, this point is x1, let's call it is a. So this is going to give you the equation of the perpendicular bisector. Now if you know you have done that, you need also to do this same process with another point. So let's take BC. We are going to find the gradient of BC, and then also find its perpendicular bisector. So find its midpoint. Its midpoint is going to be there using the same procedure, and then find its perpendicular bisector. So it's going to go like that. So you can see that it is making 90 degrees. So what you need to get to know is that where these two perpendicular bisectors intersect is going to give you the center of that circle. So that is going to give us a center. The intersection of these two lines we have found is going to give us the center of our equation. And so if we know the center, how do we find the equation? Equation is given by x minus a squared plus y minus b squared is equal to r squared. Well, we know the center, we know the value for a, we know the value for b. What we are just remaining with to know is the radius. Now this radius, how do you find it? So if you just know the center, and then any one of the coordinates that you are given, find the distance as we saw earlier. So the distance may be between the center, say the center is here, and then you have got this point B which is here. Just find the distance of this. And how do you find the distance? Distance is given by x2 minus x1 squared plus y2 minus y1 squared. We don't want to square root, so let's leave it as r squared, so that if we want to find r, then we are going to square root on both sides. But let's leave it like this. That means we are going to find the value of r squared if we substitute in here. And if we do that, we just put that value we have found at this point. We would have found the equation of a circle. Well, to understand all this that is in theory, let's look at some practice questions. So we've been given that the equation of a circle is given by x squared plus y squared plus 4x minus 10y minus 7 is equal to 0. Now I want to find the center and also the radius. Well, before we do that, the first thing that we want to do is we need to express it in the form x minus a squared plus y minus b squared is equal to r squared. So this is the form that we need to express, and then this is going to give us the x value of the center, the y value of the center, like that. So let's get that equation. So what we have is x squared plus y squared plus 4x minus 10y minus 7 is equal to 0. So at this point, we'll take those which have got x on the same side. So that will give us x squared plus 4x. And then those with y is to the same side, we have got first y squared minus 10y. I can take 7 the other side to be positive 7. Now I'm going to complete the squares for this one alone. I'll complete the squares for this one alone. So if you have got x squared plus 4x, when we are completing the squares, this one is already having a coefficient of 1, so we don't need to worry about that. So all we do is we are going to get x, this one, without a square. We are going to get the half of this number, which is, let's say half of 4. The half of 4 is a 2, so that will be positive 2. And then we put a squared outside, and then we always subtract. Now square this number which is here, that is going to give us a 4. So this is the same as this, So we have completed the square for that one. Let's go to the one which has got y. So that is y squared minus tan y is equal to, we are going to write y and then minus, so because we have got a minus there, we are going to get the half of 10. The half of 10 is a 5. And then we are going to put that one inside and then square it and then subtract always. What is the square of this number, which is the square of negative 5? It's a 25. So that is it. We have completed the square. So where there is this, I'm going to substitute this portion. And then where there is that, I'm going to substitute this. So that is giving x plus 2 squared minus 4. And then we have got a plus here. So plus, where there is that, I'll put y minus 5 squared minus 25. And that is equal to a 7. Now, I'll take every constant to the other side. And so that is going to give x plus 2 squared plus y minus 5 squared is equal to 7. The 25 going that side, it becomes positive 25. The 4 also becomes positive 4. So this gives x plus 2 squared plus y minus 5 squared is equal to, so the aim is just to add 7 plus 4 plus 25, and that is a 36. Well, we know that the form, the error is squared, so we need to write 36 as a square. So that is going to give us x plus 2 squared plus y minus 5, that also squared, is equal to 6 squared. So this is telling us that the radius, first the center. The center is given by, we get this coordinate, just change its sign, that is negative 2. Get this one, change its sign, that is positive 5. So the center is at negative 2, 5. Okay. Finding that, let's go on and find the radius. So the radius is going to give us what? The radius is going to be this number which is squared. So the radius is a 2. So that will be it for this one, the center and also the radius. Now, to determine its area, how do you find the area of this thing? Okay. We know that if we have got a circle, the formula for area of a circle is given by what? Area of a circle is given by pi r squared. And so the area is going to be given by pi. The radius, we know it's okay, the radius is not 2. This was a 6 which was squared. Sorry, that is not it. So the radius is 6 squared. So therefore the area is 36 pi. It is units squared. Whatsoever the units, if it's centimeters, the units are going to be squared. If it's meters, the units are going to be squared also. Alright, we have got this one. Given that the circle has got a center 2, negative 5. The question is, and the radius of 3, what is the equation of this circle? Now, how would we determine the equation of a circle if you've been given the center and the radius? Well, this is much direct. We know that got x minus a squared plus y minus b squared is equal to r squared. So all we do is this value of x is what we are going to put there. That will be x minus 2, and that is squared, plus y minus, the value for y is negative 5. So negative by negative 5, that will give us a positive 5 squared. And then our radius is 3. 3 squared is a 9. So this is the equation of this circle. Now we want to find its area. Area, we know it's just pi radius squared. So that is pi. The radius is 3 squared. So this is giving us 9 pi units squared. So that is it. Given another one here, the equation y is equal to 5x minus 13 meets the circle. So that is actually the line, the line that has got that equation is the one which meets the circle. Now the equation of the circle has been given. So the equation of the circle is x minus 2 squared plus y plus 3 squared, and that is equal to a 2. Okay, at the points A and B. So let's just try to see what is happening here. We can just try to see the diagram which we are talking about at this point. So the center of this circle is at, we can see that x, this one is negative, so that means the center is at positive 2 comma negative 3. This one we are going to change its sign, so that is where the center is, 2 comma negative 3. So let's say 2 is here and negative 3 is there. Okay, now what is the radius of this circle? This is saying is equal to, alright, so this value here is a 26, not a 6. So that is supposed to be a 26. So that means the radius is equal to the root of 26. Because we know that the equation of a circle, that portion is given as r squared. So this number is actually squared. For you to get r, you need to write it as a square. So that is the square root of 26 squared. Because 26 is not a perfect square. Okay, and we know approximately the root of 26 is about 5.1. So that is telling us from this center which is here, we have got a center here. The radius is the distance of a point away from the center. So that is telling us that we are moving about, the root of 26 is about 5. So the radius is around approximately 5.1. So we are going to move 5 units from the center in all directions. Well, if this is the point 2, if we move 5 units from 2 in this direction, where are we going to reach? We are going to reach at 2 plus 5, that is somewhere 7 point something. So let's say 7 is here. So it will just be slightly above that point there. And then we are going to also move 5.1 units to the left. Now from here to 1, that's 1 unit, to 0 is 2 units, to negative 1, 3 units, to negative 2, 4 units, to negative 3, that is about 5 units. So you need to take out those steps are moving. Well, let me just show this point here. We have got negative 1, a 1 there, negative 1, negative 2, negative 3. So the radius is telling us how many units we are moving. So we are moving 1, 2, 3, 4, 5. So it is just slightly above 5. Okay, so it will be very near 5. So it is going to be, it should be straight up to that point somewhere there. Though the distances don't look the same. Okay, something like that. Even this point, let's say 7 is somewhere there. Okay, and then we are also going to move 5 units on top. So this is 3. So remember there should be a negative 2 here and a negative 1 and then a positive 1, 2. So 5 units, that would be 1, 2, 3, 4, 5. It's going to reach somewhere positive 2, just slightly above positive 2. Okay, somewhere like that. And then also 5 units down. So from negative 3, that would be negative 4, negative 5, negative 6, negative 7, negative 8. So we are moving 5 slightly above 5 units, that is 1, 2, 3, 4, 5. So it will reach somewhere at negative 8, just slightly above negative 8. So it will be somewhere there. Now it is these points that we just need to join, and that will be a circle. So just need to make sure that we make it as smooth as possible. So it is something like that. Well, we're not even interested in that, but it is very important for us to understand how it's just going to appear. Now, part A is asking us, show that the coordinates of A and B are 1, negative 8 and 3, 2. So, we know that there's an equation y is equal to 5x minus 13. So, 13, negative 13, that is the y-intercept. That is meaning the graph is cutting. This line is passing at negative 13. Negative 13 will be somewhere here. That is the intercept, y-intercept. And then the gradient is positive. So if the gradient is positive, that means the equation goes like that. If it was negative, the equation would have gone like that. Now gradient is found by y over x. So if y is 13, what number should we divide by 13 for us to get a gradient of 5? So we just need where it is going to pass. So 13 divided by x is equal to 2. So 13 over 2, that is somewhere 6.5. So this graph, this straight line will pass somewhere, just somewhere here. So if we draw this line, it's just a sketch anyway, it's not exact. So a y-intercept is at 13 and then it passes somewhere there. So this is how the graph moves, something just like this. Now there are these points, there is this point and then there is this point. We don't know which one is A, which one is B, so any of this can either be A or B. Okay, like that. Now let's calculate those values. So the equation of this circle is x minus 2 squared plus y plus 3 squared is equal to 26. And then we have got y is equal to 5x minus 13. Now since these lines are intersecting, that means at the point where they intersect, the y value and the x value is going to be the same. So this equation where there is y on the circle, we're going to put 5x minus 13. So this will give us x minus 2 squared plus y. Okay, where there is y now we are putting 5x minus 13, and remember that is plus 3 squared, and that should be equal to 26. So this is x minus 2 squared plus, this is going to give us 5x, that should be minus 10 squared is equal to 26. Now we can do expand at this point. If we want, we can square root on both sides, but this is it's not a perfect square, so that will give us decimals. Okay, so let's expand this. If we expand that, that will give us x squared minus 4x plus 4. And then if we expand this one here, it's going to give us 25x squared minus 100x, and then plus 100. That is going to be equal to 26. So we're going to put like terms together. So this one we are going to add it to that one. So x squared plus 25x squared, that is going to give us 26x squared, and then negative 4x minus 100x, that is going to give us negative 104x, and then we have got this constant plus the 100, that will give us 104, but that 104 we are going to take it the other side, and then it will be 26 minus 104, that is going to give us a negative 78. We can take this 78 the other side to become positive, that will be 26x squared minus 104x plus 78, and that is going to be equal to a 0. Well, at this point 26 can go into all these numbers, so divide through by 26, so that will give us x squared there. 26 into 104 is a 4x. 26 into 78 is a 3, and that is going to be equal to 0. Now I need to find the product, since this is a quadratic equation. Product is the number in front of x there is 1, and then multiplied by the constant 3, that is the 3, then the sum is negative 4. So two numbers, when we multiply them we get 3, when we add we get negative 4. It's negative 1 and negative 3. So this will be x minus 1, x minus 3, and that is going to be equal to 0. So to find the value of x, we're going to equate each of these to 0. That means x is equal to 1 or x is equal to what? 3. So those are the x values. Now to find y values, we need to go to the equation which we have at that point. So the equation is y is equal to 5x minus 13. So what will be the value of y when x is equal to 1? So y is going to be equal to 5 times 1 minus 13, and that is 5 minus 13 is a negative 8. What of when x is equal to 3? The y is going to be 5 times 3 minus 13. 5 times 3 is a 15. 15 minus 13 is a 2. So we are seeing that, let's say this one on the on the negatives is a. So the x value we've seen is supposed to be positive, while the y value is supposed to be negative, as you can see there. So the one which has got a y value which is negative is going to be a. So a is going to give us 1 comma negative 8, and then b is going to give us what? X value is 3, y value you have found is 2. So that is it. As we can see, those are the ones. Hence we have shown that first part. Well, what of the second one? Now we've been given that M is the midpoint of AB. So AB, we have got this point A and the point B. M is the midpoint somewhere here. That is where we're going to find the M. Okay. Now find the equation of the line which passes through M and is perpendicular to AB. When that line, if you want to find something that is perpendicular to AB, that means we are drawing, it passes through M, but it is making 90 degrees to the line AB. Something like this. Okay, like that. It's the meaning of perpendicular. Okay, let's go on and see how we are able to do that. So it's making 90 degrees here. So the first thing that we want to find is the value for M. Now M is a midpoint, and how do we find midpoint? Midpoint is given by x1 plus x2 divided by 2, then y1 plus y2 divided by 2. So x1 we've seen is 1, x2 is a 3. The coordinates we are getting are these which are here. That's the value of the point A and the point B, and then that divided by 2, comma y1 is negative 8, y2 is a 2, that divided by 2 also. So this is going to give us 4 over 2, which is a 2. Negative 8 plus 2 is a negative 6 over 2, that is a negative 3. So this is the point of M. These are the coordinates of M. Now we need to find the gradient of this M. Since this line is passing through M, well, first thing we need to find the gradient of this line AB. So we'll go on and say gradient of AB is given by change in y over change in x. Now how do we find change in y? Change in y is given by y2 minus y1 over x2 minus x1. Now y2, let's get this as the 2's and then this as the 1's. So this will be y2 is a 2 minus y1, which is negative 8, divided by x2, which is a 3, minus x1, which is a 1. 2 minus negative 8 is a 10. 3 minus 1 is a 2. So this is giving us a gradient of 5. So AB, the gradient of this is 5. Even as we can see, that is of course a 5. True. Okay. And we can even tell the gradient of AB should be equal to the gradient of this straight line, which is equal to what? 5. The one we can see there. Now since we know the gradient of this as 5, we can find the gradient of the perpendicular bisector of AB. So this line which is passing through AB, through AB, and then it's passing on the point M, is making 90 degrees to AB. And so the product of the gradient M1 m2 should give us a -1. Always that is a property when two lines are perpendicular. So m1 is 5, m2 is equal to what? -1. So m2 is going to give us -1 comma 5. So this is the gradient. Now we already found the coordinate of m. We found that m was equal to, okay, so that gave us a what? Gave us a 2 comma -3. So we can find the equation of this line which is passing through here. And how do we find the equation? Y minus y1 is equal to mx minus x1. So y1, this is just a point where the line is passing. The line is passing at -3, so that will be -3, and that will be equal to m, the gradient through which it is passed. The gradient of this line is -1/5, -1/5, and then x1, this is the value there, which is a 2. Now at this point we just want to do away with the fraction, so we do away with the 5 down there, so we multiply by a 5. So what we are going to have is y times 5, that is going to be 5y. This is going to be a positive number here, so it will be +3. So +3 also times 5, that will be 15, and that will be equal to, well, this 5 and this 5 are going to cancel out, so just remain with a -1, x minus 2, and so it will give us 5y plus 15 is equal to -x plus 2. And this will give us 5y is equal to -x. We're going to take the 15 the other side, that will be -15, so that will be plus 2 minus 15. This will give us 5y is equal to -x. 2 minus 15 is a -13. So depending with which form they want us to leave our answer, if they don't want any specified form, we can leave it like that, or we can take all the terms to the one side, and that would be 5y plus x. Okay, and then we have got plus 13, and that is going to be equal to a 0 like that. In any form that would leave it, it's all the same. And so that is going to be the answer then for this one. Now a last question here. Find the equation of a circle that passes through the points 1, 4, 7, 5, and 1, 8. Now if we can just try to sketch these points. Alright, sorry for that. So if we just sketch these points, let's put them like that. X and y. So x is up to 7. So say this is 2, 4, 6, 8. And then you can also say 2, 4, 6, 8. Alright, so the first point that we have is 1, 4. 1, 4 will be somewhere here. So 1 is going to be here for x. So this point is going to be here. And then I've got 7, 5. 7 will be somewhere here. 5 will be on the middle there. So put it somewhere there. And then you've got 1, 8. 1 is there, so 8 is there, so it passes there. So this circle we want to draw should pass through these 3 points. Now we don't know how it's going to pass, so it can go something like that. It's supposed to come and pass through this point, and we know it is supposed to pass through that point. Okay, something like that. Alright, now we need to get this some 2 points. We find their perpendicular bisector, and then some other 2 points their perpendicular bisector, and then solve simultaneously those 2 perpendicular bisectors. So if we get these 2 points, let's say this is point A, this is point B, this is point C. We need to join these like that to find the perpendicular bisector. So the first thing that we want to find is the gradient of AB. Now this is a straight line. It's a line which is parallel to the y-axis. So it's not necessary to find this gradient. Actually, the gradient is infinity. You can't find the gradient for a straight line that goes up. So it's perpendicular bisector. We just need to find the midpoint for AB. So midpoint of AB, that is going to give us x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So our x1, so we're coding this as our A is 1. Our x2 from this one is still 1. And then divide that by 2. And then y1, the y value is 8. And then the y value here is a 4. Divide that by 2. So this is going to give us what? 1 plus 1 is a 2. 2 over 2 is a 1 still. 8 plus 4 is a 12 over 2 is a 6. So this is the midpoint. Now we know that the perpendicular bisector is supposed to make 90 degrees to this straight line which we have here. So if we draw the perpendicular bisector, let's say the midpoint is at 6 here as we've shown. So it's going to go like that. Now what is the equation of this line which we have shown? The perpendicular bisector. So the equation is y is equal to, we just get the y value because this is a straight line which is parallel to the x-axis. So it is y is equal to 6. We can get any other two values, any other 2 points, and find the perpendicular bisector. So we get point B and point C. We join them. Okay, in that manner. So let's find the midpoint of this point first. The midpoint of BC. So midpoint BC is going to be equal to the x-coordinate of B, that is 1, the x-coordinate of C, that is 7, divided by 2. We'll go to the y-coordinate of B, which is a 4. Is that really a 4 or a 5 at which it's passing? Okay. So it is a 4. And then the y-coordinate of C is a 7. Okay, the y-coordinate, sorry, is a 5 for this point which is here. The one which we are drawing at the middle between 4 and 6. So that is 4 plus, that is a 5. And then we're going to divide that by a 2. So this is going to give us 1 plus 7 is 8. 8 over 2 is 4. Then 4 plus 5 is a 9. 9 over 2. You can just write it as 9 over 2 instead of decimals. So this is the midpoint. So the midpoint of this line is somewhere here. Now we also need to find the gradient of this line. So the gradient of AB is given by change in y over change in x. So y2, let's consider this as 2, this as 1. So y2, the y-coordinate of C is a 5, minus y1, the y-coordinate of B, that's a 4, and then divide by x2, the x-coordinate of B, of C, I mean, is 7, the x-coordinate of B is a 1. So that is giving 5 minus 4 is a 1, 1 over 6. So this is the gradient. So if we want to draw a perpendicular bisector of BC, that is going to pass straight like that. So what will be the gradient of this perpendicular bisector? So the gradient M1, M2 is going to give us negative 1. So because they're making 90 degrees here, so if we multiply the gradient of BC, that is 1 over 6, by M2, it should give us negative 1. And so that gradient is M2 is equal to, you can simply multiply by 6. So that this 6 and this 6 cancels. And then 6 times the negative 1, that will give us negative 6. So this is the gradient. Now, since we know the midpoint, this point here, and then we know the gradient, we can find the equation of that line. So let's keep the gradient there, and then the midpoint of BC, also very important. So let's go and find the equation. So we know that y minus y1 is equal to m x minus x1. So this is y1, we found that point there. It's 9 over 2 should be equal to, the gradient is negative 6, x1 is a 4. Okay, so like that. Now let's just make sure that we don't have a fraction here. We can multiply by a 2, so that is going to give us 2y, then this 2 and this is going to cancel out. That will be minus 9, and that will be equal to 2 times negative 6, that will be negative 12, x minus 4. So we go on and do the simplification. That is going to give us 2y minus 9 is equal to negative 12x plus 48. So take 9 the other side. That is going to give us what? 2y minus 9, that is going to be equal to, okay, that is going to be equal to, we are taking 9 the other side, so this will be 2y is equal to negative 18x, 48 plus 9, so the 9 will add up that side. That is going to give us 57. Okay, so this is the equation the other side, and this is a 12. It's looking like an 18. This is a 12 here, so a 12 there, even the 12 here. So this is the equation of this line. So we are saying 2y is equal to negative 12x plus 57. Now we've seen that these two perpendicular bisectors, this one and this one, are intersecting at this point. Actually, the point at which two perpendicular bisectors intersect is the center of the circle. So we're going to solve those two and find the value for that point. So we are getting 2y is equal to negative 12x plus 57. So we have got also this equation. Now where there is y, we're going to put 6. So that will be 2 times 6 is equal to negative 12x plus 57. I can take this 12 the other side to be positive 12x is equal to 57 minus, this will become a positive 12, goes that side. I mean a negative 12 the other side. So that is going to give us 12x being equal to 45. So 12 into 45, that is going to give us x being equal to about 3.75. So that is 3.75. Now better we write it as as just a fraction. So that is 15 over 4. If we divide 12, even there 12. Now let's find the value for, of course we already know the value for y, so there's no need of finding the value for y if we already know it. So that means this point which we have here, the center, the x value is 15 over 4, the y value is 6. Now we know the center. What is the radius of this circle? So if you just know the center, you can just get any one coordinate and then you are going to be able to find the radius. So just connect any one coordinate to the center, then that gives you the radius, and then we're going to find the equation of that, I mean the distance of that line, the distance of the line A. This is the center here, let's call it P. So how do you find that distance? That is going to give us radius, and that is r squared. R squared is given by x1 or x2 minus x1 squared plus y2 minus y1 squared. So this will give us r squared being equal to x2. Let's take the center as 2. So x2, that is 15 over 4 minus x1. The x1 is coming from the point A. The value for x there is 1 squared, and then plus y2. y2 is 6. y1 is coming from here, that is 8. Well, that's squared. So that will give us r squared being equal to 15 over 4 minus 1, and then squaring that answer we get, that is 121 over 16, and then plus 6 minus 8 is a negative 2, negative 2 squared is a 4. So we can add now 121 plus over 16 plus 4, That is 185 over 16. Okay. So that is giving us to say r squared is equal to 185 over 16. Now we know the general form of a circle. We can now go on and write it. So we know that the circle is given by x minus a squared plus y minus b squared is equal to r squared. X minus our a, that is the center, the x value of the center, 15 over 4 squared. And then b is y minus b, the y value of the center, that is 6 squared, is equal to r squared. The value of r squared is 185 over 16. So this gives us the equation of this circle which we have at this point.